Today, we're going on a bit of a conceptual journey. We're doing a deep dive that is uh, dedicated entirely to improving the very foundations of how you think.
Mm-hmm.
We're going to be focusing on epistemology, which is just the theory of knowledge.
Mm-hmm.
And we're looking at it through the lens of the physicist David Deutsch and his intellectual ancestor, the philosopher Karl Popper.
And, we aren't just doing this to talk about some dusty old philosophy.
Right.
The sources we're looking at make a pretty massive claim. They say that really internalizing this framework from Deutsch and Popper, and I'm quoting here, is the easiest way to actually get smarter, fix your epistemology, and fix your thinking.
And that really is the mission for us today. Our target is to dismantle what is probably the single most common and most flawed view of how science actually works, of how all reliable knowledge grows.
Yeah.
We have to challenge this idea of the scientific method that everyone learns, because if you don't get how knowledge works, you really limit your own ability to create it.
Exactly. And to frame this, Deutsch talks about 4 core strands that kind of weave together to form what he calls the fabric of reality.
Okay.
You've got evolution, quantum theory, computation, and the one we're focused on, epistemology. The theory of knowledge. How we gain knowledge is the engine of all human progress. And the standard textbook definition of that engine, it's just plain wrong.
So let's lay out that myth, the view that almost everyone holds. We all got it in school, and it goes something like this. Step 1, you go out, you make pure, unbiased observations. Step 2, based on all this data you've collected, you form a theory. They call that induction. Then step 3, you test that theory against more and more observations.
And the idea is the more data you get that agrees with your theory, the closer you get to the truth, until finally the science is settled.
Right, the final answer.
And that entire structure, as Karl Popper spent his entire life arguing, is it's fundamentally flawed. It's not just a little bit off. The sources call it a series of deep misconceptions. It completely fails to describe how genuine knowledge actually grows.
But it feels so intuitive, the idea of induction. I see 1,000 white swans, I see another one and another one. So I feel confident saying all swans are white.
Yeah.
Where does a system like that break down?
It breaks down before you even leave the house to look at the first swan.
Okay.
That very first premise, that knowledge starts with pure passive observation, is impossible. Popper established that all observation, every single sense impression, even measurements from the most advanced scientific instruments, they are all fundamentally theory-laden.
Theory-laden. That's a term we need to sit with for a second. If I just look at a screen, I see a screen, what theory is loaded into that?
Well, the thing is, you're interpreting it. You're seeing it through all these existing fallible frameworks you already have. You need a theory of optics to understand how light works, a theory of material science to even know what a screen is.
Right.
And even a theory of human perception to trust what your own senses are telling you. You never ever encounter pure data. Think about an astronaut looking at the moon. They don't just see rocks. They see geological consequences, impact craters, machine tracks. Those are interpretations.
They're based on theories, not just raw sense data.
Exactly.
So if we can't start with pure observation, where does knowledge actually begin? If not with gathering data, then what?
Knowledge begins with a problem.
A problem.
It starts when you recognize a conflict or a gap. Something that contradicts the knowledge you already have, which is, by definition, full of all these fallible theories. The goal of science isn't affirmation. It's about identifying and solving discrepancies.
That just flips the whole process on its head. It shifts from seeking validation to actively seeking out contradiction.
Precisely. The process is one of conjectures, which are just theories or guesses, and then you subject them to rigorous criticism. The sources point out that every PhD student in a functioning lab is basically trying to produce something that contradicts or overturns what we currently accept.
So their job is to find the flaw in the current best idea.
That's the core job.
Okay, so if the whole goal is contradiction, how does that change the role of an experiment? Because in the popular view, the experiment is what proves the theory right.
In the Popperian view, an experiment is often useless unless there's already some kind of conflict to resolve.
A conflict between what?
Between a rival theory or maybe an inconsistency within one theory that you need to clarify. The process, especially in a field like advanced physics, is described in the sources as being essentially debugging.
Debugging. Like with computer code. What does that mean here?
Well, think about building something like the Large Hadron Collider. You don't just switch it on and poof, discover a new particle.
I assume not.
No. You turn it on, and 99% of the time, it doesn't work. The data you get is just nonsense. And you don't immediately say, oh my God, the laws of thermodynamics have been violated.
Right, you assume you messed something up.
Exactly. You assume there's a bug in the code, a faulty sensor, some misunderstanding of the materials. You create conjectures to fix the machine, and you criticize those conjectures until the machine finally works according to the existing laws of physics.
So when you get a weird result, your first thought isn't to tear up the textbook. It's to check your own work.
Yes. We only ever really discover a true violation of the laws of physics if we already have some kind of rival theory that suggests where the current explanation might break down. If you only have one theory, the rational response to a weird experiment is almost always something we didn't know about was affecting the result.
So the experiment's real value is in helping us choose between competing guesses.
That's where its power lies.
Okay, this makes sense. We're constantly making guesses and then trying our best to break them. But that raises a really important question. If all our theories are just fallible conjectures, and we can never be certain, what separates a good theory from a bad one?
Right.
What makes one guess worth taking seriously enough to even criticize? And that brings us to David Deutsch's concept of a good explanation.
Yes, and a good explanation is really what drives all knowledge forward. At its most basic, an explanation is just a story that accounts for something. You know, Kipling's Just So story is how the leopard got its spots. Those are explanations, but they're bad explanations.
They sort of satisfy your curiosity for a moment, but they don't seem to lead anywhere scientifically. What's the key difference?
The core quality of a good explanation is that it's resistant to being changed arbitrarily. This is what we call the hard-to-vary principle. A good explanation is one that you can't easily tweak or swap out parts of and still have it account for the same thing.
Hard to vary. That phrase alone is such a great tool for just evaluating any idea, really, not just in science. But let's use the classic example from the sources to make this super clear.
Perfect. The best contrast is explaining the seasons. Let's start with a bad explanation. The Greek myth that spring happens because Persephone leaves the underworld every 6 months to rejoin her mother.
Right. It's a powerful story, and it does, it explains the cycle of growth and decay we see every year.
It does, but it's incredibly easy to vary. Why Persephone? You could swap in Nike or Aphrodite, and the explanation for the seasons is conceptually the same. Why Hades? Make him Poseidon or Zeus, and the story still works.
You can change the characters, the motives, the timing, and the story's ability to explain the seasons doesn't really change.
Exactly. The details are disposable because the story lacks any real deep specificity. It has no explanatory rigidity.
Okay, so now compare that to the good explanation.
The good explanation is that the seasons are caused by the Earth's axial tilt. It's angled about 23.5 degrees relative to its orbit around the sun. Now, try to vary that. Change the tilt to, say, 5 degrees. The math of how much solar radiation hits each hemisphere changes dramatically. The explanation for why our seasons are relatively mild and why the North Pole gets 6 months of darkness, it all instantly breaks down.
If you change that one tiny number, the actual physical thing we observe, our seasons, no longer matches what the theory predicts.
The theory is rigid. It's hard to vary because all its details are interwoven with other known laws of physics. It doesn't just explain that we have seasons, it explains why they're opposites in the northern and southern hemispheres, why the days get longer and shorter, and how the sun's intensity changes. It ties reality together.
So the growth of knowledge is this constant process of replacing these flimsy, easily varied, myth-like stories with robust, hard-to-vary explanations that can actually survive relentless criticism.
That's the whole game. And understanding that shift is so central to improving your own thinking. When you hear a new idea, the question shouldn't be how much data supports this, but how easily can I change this story and still have it explain the same thing?
If you can change it easily, it's a bad explanation, no matter how many people believe it.
You got it.
Okay, so let's get to the so what here. How does this non-dogmatic, conjectural view of knowledge apply when you, the listener, are faced with, high-stakes decisions in the real world?
Yeah.
The kind where you have to act fast with incomplete information.
Well, we saw this exact epistemological mistake play out on a global scale during the pandemic. The sources really highlight this. When you had people defending certain policies by yelling, "We are following the science," they were relying on that flawed popular idea of science as a source of definite, settled authority.
They were looking for certainty, which this entire framework tells us is a myth.
Correct. They were mistaking policy conjectures for settled science, when in reality, the truly rational scientific starting point in, say, March of 2020 was to admit, we do not know.
Right.
Many of those initial policies were reasonable conjectures, reasonable guesses, but they were not guaranteed truths. We were, by necessity, relying on ideas that hadn't been properly criticized or debugged in real time yet.
And the political polarization around it all. Now, that really illustrates another key idea from Deutsch, doesn't it? The separation of knowledge from motivation.
Oh, that's crucial. You cannot deduce the properties of a virus from your political philosophy. It doesn't matter if you lean towards individualism or collectivism.
The virus doesn't care about your politics.
Exactly. Knowledge about the physical world is independent of your wishes or your motivations. When people let their political theories dictate which scientific explanations they're willing to accept, they've got the whole process completely backwards. They're creating the ultimate bad explanation, one that's easy to vary based on which tribe you belong to.
So the rational response, especially in a crisis, is to always admit what we don't know and then aggressively criticize our temporary guesses rather than treating them like dogma.
And that leads us to the final and maybe the biggest implication of this whole way of thinking. If knowledge only grows by destroying bad explanations, what happens when we reject the absolute worst explanation of all?
Which is what?
The explanation that says this can't be understood or this problem is insoluble.
That sounds like a pretty depressing explanation, though sometimes it feels true when you fail at something.
It's the ultimate bad explanation because it's the intellectual equivalent of just invoking the supernatural. It's saying the laws of physics have a special exception right here, and that human ingenuity just can't work on this one problem. And rejecting that idea leads directly to what Deutsch calls the principle of optimism.
Optimism. That
Yeah.
sounds more psychological or, moral.
Yeah.
But you're saying it's actually an epistemological conclusion.
Absolutely. If we accept that all our knowledge is just fallible guesswork, but that we can always find better, harder to vary explanations through criticism, well, then we have to reject the argument that any particular problem is fundamentally beyond our understanding. We have to reject the idea that there are mysteries that can't, in principle, be explained.
So the principle of optimism is that if we reject that lazy explanation that something just can't be understood, we are forced to accept that, in principle, we can understand anything. And therefore, we can do anything that isn't explicitly forbidden by the laws of physics.
Exactly. Since understanding is tied to physical action, you know something because you can build something or predict something with that knowledge. Our only real limit is a lack of knowledge. And a lack of knowledge is, by definition, a soluble problem.
The only thing that's truly impossible is what the laws of physics forbid. Everything else is just waiting for a better explanation.
A better, harder to vary explanation.
That's a staggering shift in perspective. It redefines what humans are capable of. We're not just limited beings. We are universal explainers, and therefore universal problem solvers.
And that really brings us to the final thought we want to leave you with, which comes right from Deutsch's philosophy. If every interesting problem is also a soluble problem, then take a look at your own life or your own field of work. What long-standing, seemingly impossible challenge must you now see as fundamentally solvable? Solvable through ingenuity, through persistent criticism, and through the active search for a better, harder to vary explanation. Because if it's not forbidden by physics, the only thing stopping you is the absence of knowledge. And that's just a problem waiting for your next conjecture.
A profound challenge. Thank you for guiding us through that. It's a lot to think about.